This is Team A04 from Professor Murray's AAE 251 class. I'm Josh Borden.
I'm Aaron Nordhoff. Levi Irvin.
Luke Mlakar, and this is A04 Freedom. Our group determined 4 important stakeholders for this project. 1, the United States government that is responsible for making the initial investments on the project. 2, the Air Force responsible for overseeing the production and development and deployment of this aircraft. 3, the manufacturers who produce the aircraft, and the taxpayers who have fronted the initial cost to fund this project. Some interesting requirements about our aircraft is that it had to be able to hold 2 squadrons of people, along with the pilot, co-pilot, navigator, and the medical personnel. Also, the pilot should be able to learn how to fly the aircraft in the same amount of time he should be able to learn any other aircraft. The craft must have sufficiently sized doors for loading and unloading cargo of various sizes. Potential risk for this aircraft is that it may be too heavy for it to actually lift off the ground, or the aircraft could be shot down over enemy lines and the advanced technology could fall into the wrong hands. It's also really expensive, having 4 really expensive engines. The last risk that we calculated was that if the plane ever had a bird strike, the engines could clog and result in the loss of a life or aircraft.
To get the initial sizes for our aircraft, we decided to compare our requirements of our aircraft to the performance of the C-17. This was just simply to get a basic idea of what size our aircraft should be. From there, we determined the size of our aircraft from the requirements we were given and the ones we decided on ourselves. So as you can see, the wingspan and the wing area of our aircraft is similar to that of the C-17. However, they are a little bit smaller because the empty weight of our aircraft is marginally smaller than that of the C-17. Now, as for engines, to decide that, we looked at 3 popular large cargo aircraft engines and compared them. Now, we ended up deciding on the Russian-made D-18T over the Pratt & Whitney F-117 PW-100 because it gave us more thrust for the weight of the engine itself. Now, like most modern military cargo planes, we decided to use a 4-engine configuration on our aircraft because it would give us the most thrust for the weight that we used on those engines themselves. Here's a selection of the various views of our aircraft. As you can see, we do have a rather wide fuselage because the cargo space we needed to be pretty big because of what we had to transport. The wing size and wing area was determined, like I said, by comparing the sizes of the C-17 and the C-130 with a higher focus on the C-17 because it has more similarities in performance to what our aircraft has to do itself. Next comes the cargo bay. To determine the size of the cargo bay, we began with the number of pallets we had to hold. So we were tasked with transporting 44 463L master pallets. The way that we decided to do this was to stack them in 2 rows, with the shorter side, the 88-inch side, running along the length of the cargo bay, and the 108-inch side running the width. So this allowed us to have 2 rows of 22 pallets. The width was also affected by the seats for troops and the aisles for the troops to move. As you can see, we don't have a whole lot of troop transport, but the seats are there for them to be able to sit. To determine the height of our cargo bay, we decided to use the M104 Wolverine Heavy Assault Bridge. This is by far the tallest piece of cargo that we'd have to hold, so if it could fit, we could fit every other piece of cargo that we would be asked to transport. Here's a look at some other military vehicles that we are able to transport in the cargo bay of our aircraft. So with the length, width, height, and weight taken into account, we can transport 2 M1A1 Abrams tanks, 6 M2, M3 Bradley infantry vehicles, or 2 AH-64A Apache helicopters.
The performance of the CA-4 Freedom was determined through the use of multiple equations and their derivatives. The coefficients of lift and drag were found using the NACA 23012 airfoil chart at an angle of attack of 2 degrees, giving a coefficient of lift of 0.3 and a coefficient of drag of 0.006. These coefficients were then used to calculate the lift and climb of the aircraft. The range of the aircraft with a payload of 300,000 pounds, as calculated using MATLAB, is roughly 3,400 nautical miles, and the endurance with the same conditions is 6.8 hours. With all 4 engines, the aircraft is able to climb at a rate of 6.37 feet per second, up to a maximum height of 62,000 feet. Unfortunately, the takeoff distance is nearly 20,000 feet, much greater than the required distance. This is due to the enormous weight of the aircraft and the less than ideal airfoil that we had to use.
So these are some of the dimensional values for our aircraft. As you can see, the length is about 177.5 feet long. For comparison, the C-17 is 174 feet in length. The height is 60 feet, and again the C-17 height is 55, and wingspan 160 feet, and the thrust, which is remarkably high due to the enormous engines we decided to put on there. So a couple of lessons we learned throughout the design process and creating this aircraft was that weight is something that we need to be considering the entire course through the design process, because it's easy for that to kind of get out of control. And then we need maximum thrust, which we did happen to achieve, and the lift to drag ratio is also very important due to the fact that we have trouble taking off on a normal length runway. And finally, in congruence with those 2 points, is that in choosing the engines and the airfoils, we need to make sure that we spend a lot of time on deciding which ones are the best fit for our applications.